Welcome to our solar system series, where we explore the fascinating formation of the Sun. Let's embark on a journey through cosmic events that led to the birth of our star. By the end of this lecture, you'll understand how stars form from molecular clouds, define what a protostar is, grasp the concept of hydrostatic equilibrium, describe nuclear fusion in the Sun, and identify the Sun's position on the main sequence. Stars are born inside giant molecular clouds, which are cold and primarily composed of hydrogen. These clouds are the stellar nurseries where the magic begins. The journey of star formation begins with gravitational collapse, triggered by events like supernova shockwaves, cloud collisions, and internal density fluctuations. Once gravity overcomes internal pressure, the collapse starts. When the mass of a cloud exceeds the critical Jeans mass, gravity wins, leading to collapse. Larger mass and lower temperatures make this process easier, setting the stage for star birth. As the core becomes denser and temperature rises, accretion continues, and bipolar jets may appear. This marks the formation of a protostar, a crucial step in stellar evolution. During the accretion phase, the core's density and temperature increase, powered by gravitational potential energy. Matter falls inward, and bipolar jets may appear, fueling the protostar's growth. Hydrostatic equilibrium is the balance between inward gravitational force and outward pressure force. When achieved, it results in a stable star configuration, essential for a long-lived star. As contraction continues, the core temperature rises to about 10 million Kelvin, initiating hydrogen fusion. This marks a critical turning point in the star's life cycle. The Sun shines through the proton-proton chain, where hydrogen nuclei fuse to form helium, releasing energy as gamma rays, neutrinos, and positrons. This process powers the Sun's brilliance. Hydrogen fusion ignites, stabilizing the core temperature and achieving hydrostatic equilibrium. The Sun becomes a stable, shining star, marking its birth in the cosmos. The Sun is now a stable main sequence star, steadily shining through hydrogen fusion. This stage lasts about 10 billion years, marking the prime of its life as a middle-aged star. Inside the Sun, energy moves outward from the core through the radiative zone, where photons are radiated, and the convective zone, where energy is carried by rising hot gas, reaching the surface. The formation of the Sun spans millions of years, from cloud collapse to protostar, pre-main sequence, and finally the main sequence, where it shines for tens of millions of years. The Sun formed from a collapsing cloud of gas and dust. Gravitational contraction heated the core, igniting hydrogen fusion at around 10 million Kelvin. Now the Sun is a stable, shining star in the main sequence.